Hello everyone. Today I'm going to be showing you how to add a protection circuit to an 18650 cell. In my case it's going to be the NCR 18650B, this Panasonic cell right here. Now if you've been watching my videos, you may have seen the one where I actually was testing the Olight 3400 milliamp cell and I overamperaged it, and well, here are the charred remains of what's left when that happened. And not the Olight's fault, my fault. This cell was not protected against over amperaging, so basically I cooked the protection circuit doing that. But again, can't fault Olight for that. My fault for not knowing that it was not protected against that. But regardless, I ended up with this NCR 18650B, the Panasonic 3400 milliamp cell, left over from that, and I want to put the protection circuit back on it. I want it to have this thing back as a protected cell, so I'm going to show you how to do that in this video. Alright, here on the screen you can see the actual circuit that I bought. It's actually a circuit kit, which is why I bought it at eBay. It's $2, $1.99. The price will change over time, I'm sure, but as you can see, it's a 5 amp protection circuit. And what I liked about it compared to what I saw on Amazon, which was a 6 amp protection circuit, which would have been fine too, but the one on Amazon doesn't have any specifics as to what its parameters are for cutting and cutting out an amperage, over amperage, and so on, over voltage, over discharging. It doesn't state any of that stuff. It just says it's a protection circuit, right? So it doesn't really say what the parameters were. So I went with this one on eBay, and you can see down here when I scroll down to the body of the sales copy, and the actual parameters are all there, and so therefore I have specifics or specifications to actually test against. That's one of the major reasons why I bought it from eBay, but it is available on both Amazon and eBay, and you'll be able to get the links for both of those in the video description. Unfortunately, I can only vouch for the one I bought on eBay. Now, the other thing I liked about the eBay kit is that the circuit actually came with the leads already pre-soldered on there, which was a nice feature. Also came with a heat shrink for each circuit, as well as the bottom cap for the circuit, which was a plus. Now the top insulators or the top pieces, those you're going to have to get yourself. They do sell them on eBay as well. I'll put some links for those in the video description below again. Here's one of those insulators off one of the batteries, and I actually made one out of a hard piece of plastic myself, so not impossible to make your own. And you're going to need those for the top end of the battery as well. But this seemed to work out pretty well. For me, I'm going to test this circuit once I get it all on the battery, on the cell, and to make sure that it's up to snuff. In other words, all these parameters that they actually say this circuit provides, it actually delivers. So we'll be doing that later after we put the cell together. Okay, I'm going to do a little forward here on protection circuits. Basically, get a protection circuit that actually fits the cell you're putting it on. In other words, that the parameters that the cell is being protected by, the protection circuit, are correct. In other words, if you have a 5 or 10 amp cell, make sure you get one a protection circuit that reflects that. In other words, it can go up to 10 amps before it protects it, or in my case, mine can, but I've taken it up so 5 amps is appropriate protection for me. So up to you, but just match the protection circuit to the cell or battery you're actually hooking it up to. Okay, in my case, it's a single cell 18650 NCR 18650B, and this protection circuit I'm showing you here on eBay should do you just fine. I'll be putting links for this stuff in the video description below as well. All right, I'm assuming that you already have a wrapped bare cell, unprotected cell like this one that you want to add protection to, unlike mine here, which is basically a protected cell that I destroyed by over amperaging. But all I did is actually destroy the protection circuit that was on the top. But I'm going to have to rewrap this thing and get it ready to go, basically to look like this. So then I can add the protection circuit. So I'm going to do that quickly here and not really show in detail what I do for the wrap on this thing, because I've done a video on how to do a bare cell wrap and how to do a protected cell wrap. So next you're going to see this fully wrapped and ready to go. And I know you guys are probably asking, well, what about the insulator on the top? Well, it melted when the protection circuit melted. So I'm just going to use, I got this old Ultrafire piece of junk cell that is 66 milliamp hours, so basically it's done. I'm just going to cut the top insulator there off of that and then fit it on here. I may have to open up the hole a little bit to make the cap fit a little better, but when I'm done that, then we'll continue with the video. Here's the NCR 18650B, the Panasonic, all nicely wrapped. You can see how nice that top turned out, and I have my insulator that I cut out of a piece of plastic on the top. It seemed to fit really nice there, and wrapped just beautifully all the way around. Bottom is nice as well, and so it's now ready to have the protection circuit soldered on there. That's what we're going to do next. Here's what the protection circuit looks like. We've got the actual circuit itself, the two leads leading out of it. The short one is the negative lead. The long one is the positive lead. It goes to the top of the cell, and they're already attached or soldered in there. This is the end cap. This would be the bottom cap. It goes on the negative side of the cell, and it actually goes, well, I'll show you how it goes in a minute. But basically, if you look at the bottom, you'll see that one of the cutouts goes to the edge of the unit, and the other cutout is, straight onto the bottom, and that's the cutout on that side is for the negative. This is for the positive. So just so you can see it, let me flip it around here. You can see it again, negative here. Keep dropping it. The negative here. Sorry, positive on that side, negative on that. Okay, so I'll show you how this all fits on, and I've got it already pre-wired here, or pre-bent. You can see I put a little bit of solder on the top here, and a little bit of solder on the back of that lead as well. And that's what I'm going to use. You don't need a lot. That's all you need to actually attach it to the cell. And what we're going to do here is put the wire through correctly. And of course, again, the positive lead is the long lead, and that goes into the slot that's cut into both the edge and the side. The reason for that is it has to wrap around the edge of the cell. So let's put that on there, just like that, and the top one just goes through the bottom hole like that, and just basically fit it into the bottom of the cap like so. That's the way it's going to be situated. You can see the small lead here. Again, that's the side that's not cut to the edge, and that is the side that is cut to the edge with a positive lead. So the next thing we're going to do is solder the negative lead onto the back of the battery, and then we'll go from there. So I'm going to do a little bit of marking on the cell, just so I know where I want the leads to go. And you can see there's 3 legs on this little center contact area here. I want to go onto this leg here. You can see it there. There's 3, but that one seems like the easiest one to get at. So I'm going to mark the cell off here, and like I said, don't worry about, well, I don't know if I said it or not, but don't worry about these marker marks, because you can always wipe them off with a little bit of alcohol on a cloth or a paper towel or something like that. So I'm just putting a mark there so I know. And why? Because this long lead on the protection circuit is going to go and match up with that, but I want to match that on the bottom as well. A nice straight line to the top would be basically the best way to go, and it looks nice too, and I like a nice neat job. So I've got my mark here. I'm going to match it up at the bottom, and then I can figure out how to put the placement of the soldering on the bottom negative lead. All right, got my alignment marks there on the cell. I've noticed on the bottom protection circuit that little tab at the bottom for the negative side is just a little long. If I fold it down, it will actually come very close to the positive lead, and I don't want that anywhere near the positive lead for a short circuit. So I'm just going to cut a little bit off the top here, so there's no possibility of short circuit there. All right, put a little mark there to tell me just about where I want that negative terminal to go, basically, so I can get a nice fit on the bottom, aligned to the edge of the cell. So I've got it more or less perfect there, I believe. And let's just double check it. Make sure you got the cell all the way into the plastic. And yeah, that looks good. So I'll solder it on there, and then we'll fold it over and then do the positive lead on the protection circuit. As I said, I pre-soldered this. I put a little solder on the actual lead already, and there's a little bit on the cell there, you know, basically testing how this is going to go. And you don't need a lot, you just need a little bit, and you just need to touch it here to get it to stick. There we go. That's it. It's soldered on there. Take a look at that. I might, well, I don't think it needs to be any look at the profile. It's very, very low, so it's not going to add the height, any extra height to the actual cell itself. Looks on it like it's on there solid. I'll give it a little tug. We'll see. Yeah, it's on there nice and tight. So now at this point, all we need to do is fold it over like so. And the bottom cap should be done. There we are, just like that. So see, here's what it's going to look like. And then we'll run the positive lead up the side there. I'm going to use some Scotch tape to hold it down, make it nice and neat all the way up. And I'll show you that. And then we'll solder the top. I put a bunch of strips of Scotch tape on that positive lead to the top just to keep it secured and basically where I want it. And also I put some, I'm going to remove the Scotch tape, but I put some tape on the bottom protection circuit here just to keep it snug against the battery. I'm going to take those off before I heat shrink, and this is all optional, but I like it nice and tight and neat. And you know, this is not here really for insulation purposes, because basically we're going to rewrap this whole cell once we get it all soldered up. But you know, like I said, it keeps it nice and neat for me, and you know, it keeps it from moving, which is nice. And once I get this top soldered on, I will remove the bottom tape and rewrap this whole cell. So now we got the top pretty well lined up. I'm going to make sure it's nice and even and flush, and then solder it to the top. All right, I'm ready to solder that onto the top, and I want to show you that you want to get this lead as flat as possible against the edge, snug to the edge as possible for a nice neat job. And then you want to make sure that it's nice and taut as you solder it down. So I'm going to be holding it here. I know this is crude device grips, but it holds it really nice and snug and holds it where I need it. So I'm going to hold it down while I solder it to the top, and then we'll see what the finished result looks like. Okay, that's it. I got it soldered down. Seems to be holding on nice and tight. Got it pretty smooth. I can always sand a little bit extra off the top here if it's too rough. But it looks pretty good. Get a little bit of an edge there. There we go. Anyway, there's the top lead soldered on. Take a look at it from an angle, give you a better look at it. It's too close, huh? There we go. So you can see that it's more or less flush with the top there. I may put a little a blob of solder on the top here just to give me a little bit of a button top to it when I'm done. But right now, looks great. So at this point, I'm ready to wrap this cell and cover up all this stuff on the outside of it. So let's do that. All right, I got 68.4 millimeters in length from the top to the bottom. I'm going to put another insulator on the top like so, and you know, basically cap it off like that, so that this lead here is actually somewhat insulated again. You don't want to expose the positive to anything as well, basically as little as possible anyways. So I'm just going to put the insulator on it like that, and maybe I'll add a dab of solder before I put the insulator on top of the top, because it's very flat, as you can see, and you know, I want to make contact with that without any issue. Okay, I put a little bit of a button on the top there, just a little bit, not a lot, about that much should do. Maybe a little bit more here. There we go. And I hold down the positive lead so it doesn't lift off when I put the solder on it. The tail is sort of bothering me. There we go. And I'll sand any peak that's way too high there. As you can see, there's a little bit there. But you know, I'll just sand that off. Show you what that looks like. See the little peak there? A little bit much. Maybe put a little bit more on there and then sand it down a bit. Beautiful. Show you what that looks like. You can see that stands off a little bit. You don't need a lot. These things get, if you make your battery too long, it won't work very well. But there it is. You can see I got a nice little blob in the center there. Maybe a little sharp edge there. I'll go sand that off. But other than that, look how nice that looks. Okay, so that gives me that little raised bump that allows me to get good contact on the positive lead. I've got my terminal on here. Now we're ready to wrap. All right, here's what the insulator is going to look like when it's on there, just like that. And I cut it down a little bit. I want the, because it's already wrapped, so the insulator, actually the wrap here is actually acting as an insulator there. So it's just a little bit for the center here. I may use a little bit of glue to adhere it perfectly in the center so it doesn't move when it's heat shrinking. And we'll go from there. So I'm going to put a little bit of glue on that, and then I'm going to heat shrink the whole battery. My usual rule for the shrink wrap is 5.75 millimeters longer than the actual measurement from edge to edge. I went a little longer, maybe a millimeter extra, just to compensate for the insulator on the top, which I've now glued on there and looks like it's staying on there nicely. So let's put it into the sleeve or into the tube, the heat shrink tube here, like so. Slide it in. I'm going to measure the bottom. I'm always 2 millimeters of overlap on the bottom, and I start the actual heat shrink process from the bottom cap to the top, or the negative lead to the positive lead. So that looks pretty good. I'll measure it out 2 millimeters exactly, and then heat shrink this thing, and we'll see how it turns out. We're ready to start heat shrinking this thing, so I'm just going to apply heat to it, and then it'll shrink. Pressing down on the cell to make sure that bottom cap is nice and snug against the cell. Looking good so far. Let's keep heat shrinking. All right, we're done. There's the bottom cap, looking really nice. We'll continue on here on the top. Looks nice on the top too. Very happy with that. Okay. All right, I'll let this cool down a little bit, and then we're going to go test it. All right, one more look at the top there. I wanted to show you how much that little bit of lead actually helps in making contact with the top. So you see that little lead basically gives me a little button top on the top of that cell. So it's ready to go that way. Looking good on the heat shrink all the way around. The back looks nice too. So yeah, really impressed. Let's test it out. One more look here. I got the Orbtronic and the Keep Power 3400 milliamp hour cells next to my 3400 protected cell. Both of these are protected, so you can see that. They're the same size.
and look really nice either way. They're all very nicely wrapped, including my own. So yeah, I'm very happy with the result there. Let's look at the bottom. You can see they have a gold type bottom on them. It doesn't really matter. It's contact bottom anyway. And they have the protection circuit on the bottom as well. Took a look at the top. They all have a button top, and I can see I squashed that one down a little bit. You know, basically, just wanted to compare them and show them to you that my end result is pretty well the same as a bought protected cell. I've got my battery hooked up here to the meter. You can see I got 4.17 volts. So it's basically a full cell at that point. And what we're going to do here is the short circuit test. By far the scariest test on a protected circuit you can do, because if it doesn't go right, your wires will melt. So let's do it. Basically, I'm going to take the positive lead and short it to the negative lead and see what happens. Okay, of course it goes instantly to 0. But I don't feel any heat anywhere. The wires aren't very hot. So I think it's shorting. The protection circuit is sensing the short and letting it go. So let's take the wire off. And we go back up to 4.17 volts. So if the short circuit protection wasn't working, then the wires would have got really hot, and this value would certainly have gone down because a lot of the energy would have been drained on the short circuit. So let's try it again. Right down to basically 0. There we go. So we'll take it off. Back to 4.17. So beautiful. The short circuit protection is working just as it should. So test number 1 passed. Now the variation you're seeing there is probably contact on my test lead there. There we go. Let it go. Yeah, exactly what it should do. 0. So shorted. Now if I left it like this and it was a real short, the wires would probably melt. Get so hot that they would melt. So they're not. They're cool, and when I come back to 4.17. So short circuit protection on my homemade protected cell, working perfectly. Let's go on to the other tests. Okay, I'm going to do the over discharge protection first, which is 2.4 volts, as you can see here on the actual description. And it says that it's plus or minus 1/10 of a volt, so it could be 2.4, 2.5, or or 2.3. So it's quite a wide range there. We'll see where it ends up, but I'm using the Life program here, LIFE, and basically I want to take it down to 2.25 and see if it kicks in. We'll see where the voltage kicks in. I'm including here on the video secondary screen my meter hooked up to the actual battery itself, right to the actual terminals on the battery, so that we get the proper voltage, not skewed by the wires and so on and so forth. But we'll see what we get here. Let's just click save here, go to the charge program and see if we can over discharge it. Again, at 1 amp, low amperage. I don't want to kick in any kind of amperage protection. So here we go, start, and we'll let it go down. Notice that there's a discrepancy between the meter, my multimeter, and the actual Turnigy in voltage. About 1/10 of a volt. So right now my meter is showing 239, 237. Boom. Okay, so there is about 1/10 of a voltage difference between what my meter was showing and what the actual Turnigy was showing, which I'll go show you that here. Let's go take a look at full screen. There's the graph, and it cut off here at 2.26, which if you look at the video was probably around 2.36, and that's perfect. Now you'll notice if you look at the secondary screen here with my meter on it, that it now is showing 0.012 volts. Basically, once the circuit trips on the discharge, and you can see here the over discharge protection, that it says over discharge protection release voltage. In other words, once it cuts open on the over discharge protection, it stays open until you add 3 volts of voltage to the actual cell. In other words, in order to untrigger or undo the protection, you need to add 3 volts to the cell. So I'm going to do that next here with my charger, just by going into stopping here. I'm going to go to charge, and then I'm going to go to the PB program, and this will allow me to put a little bit of electricity into that cell, which will trigger the voltage again. So here I'm going to hit start, and the reason I'm using the PB program outside of all the others, because all the other charge programs check to see if the cell is there and whether it's functioning correctly. Well, currently it's an open circuit, so it wouldn't allow, any other program won't allow to put any charge into it. So this is how you reset the over discharge. So here I'm going to hit start, and then you can instantly see the meter goes up to 3.0. So here we're going to hit stop, and you can see the voltage is staying around 2.9, 2.81 at this point. I don't want to put a lot of electricity into it using the PB program. So yes, the over discharge protection does kick in, about within the parameters set up here in the protection, over discharge protection specifications for this circuit. So I'm happy with that. According to our chart from my eBay supplier on this protection circuit, they say the overcharged detection voltage should be 4.30 volts plus or minus 0.05 volts. Pretty accurate, but my charge program only allows me to go to 4.3. Here we go. Let me show you this, to 4.30 as well. So we'll see what happens. So we're going to try and take it up there and see what happens with the charge. Hopefully it cuts it off. So let's just hit it, see what we get. Oh, by the way, I have it at 1 amp, so the over amperage protection won't kick in. Well, it looks like it worked. Let's take a look at the voltage chart here, see what we got. Yeah, obviously it went way over up here, and I'm not sure what happened there. Let's take a look. Let's look at the current. Yeah, and the current just dropped right off. So right now it's at a discharge, a disconnected situation. Let's try that one more time. Okay, tries to charge it. Looking at voltage here. 4.29 volts. Perfect. It does cut off at 4.30, I would say. Let's take a look at the full screen on the voltage. We're up here. Yeah, 4.29 as far as I can tell. Let's take a look right at the end. Yeah, very happy with that. So over voltage works. Next, I'm going to test for over current protection, which should be, according to the specifications on that circuit we put on this NCR 18650B, should be between 5 and 8 amps. So, let's it says over current detection voltage, it says 0.15 plus or minus, 0.03 volts. So let's take it up here. I've got a current of 10 amps on this thing. I'm using the nickel metal hydride program because it seems to work best for doing this. And it doesn't really matter here. What we're doing is we're basically over amping or over currenting the cell. So let's hit the start here, and let's go over to amperage. Let's make this full screen. There we go, and you can see it spiking right up, and it hit 5.7 and then goes right back down to 0. So the protection circuit is actually working. Let's try that one more time because that was fun. You hit start, and you can see just spike. And that time it hit 8. But that is within the parameters that the circuit is set for. So it cut it off at 8 amps. Perfect. So it's both times within the parameters. Let's try it one more time here, see what we get. .6 that time. So yeah, it's definitely catching in the over amperage situation within the specified parameters. So I'm happy with that. So I'll close this off. I think that's full testing of everything. We've done the overcharge protection, over amperage protection, over discharge protection, and the short protection. Beautiful. I'm very happy with the results of this little experiment I did on adding a protection circuit to an NCR 18650B like this one. And the result was great. I mean, the protection circuit worked great. The look of the cell, the function of the cell, everything about it is every bit as good as my Orbtronic, I would say. You know, and I did it for under $10 for one cell. So basically, you can get one of these NCR 18650Bs on the net, you know, eBay or Amazon, wherever, for under $7 usually. You know, if you really shop, you might be able to get one for around $5. 3,400 milliamp hour cell. Plus $2 for the protection circuit, a little bit of heat shrink on the top of it, and you know, a little bit of your time, and you get a protected 3,400 milliamp cell that you can actually rely on. I'm very happy with the testing results on this as well. So I have no issue trusting this cell as a protected cell from now on. So quite happy with the results of this video. Hopefully you can do the same and you'll get a similar result. All right, if you liked this video and it helped you out in some way, do me a favor, click on the like button right down here and give me a thumbs up. It helps my channel, it helps my video, and I greatly appreciate it. Also, somewhere, usually around here, there'll be a picture of me. That is a subscription link. Click on that subscription link and you'll be subscribed to my channel. Also, when you're doing that, you'll see a bell next to it. And if you click the bell, you'll get a notification every time I put a new video up. And then you can watch it at your own leisure. Okay. Like always, I want to thank you all for watching and for your time.